Welcome to Rise Up Namibia. So in this video, we are going to be looking at exponential equations involving at least 95% of the type of questions you can be asked in the exam, if not all, okay? By Metianata aka the resistor of bad and the lover of good, hashtag dark and lovely underscore, walk by faith and not by sight. So, what do you do when you are given a question like this and you're told to solve for x? Now, once you look at this question, the bases are the same, okay? Now there's a rule that states if the bases are the same, the exponents are equal. So what would our answer be? Our answer would be x equals to 3. And that's our final answer for the first question. As easy as such. Now how about when you have something like this? Now, I want you guys to notice one thing. On this side of the equation, we have a 1, okay? Now, remember the zero exponent law that I taught you guys in the previous video. Now, if you didn't watch the previous videos, because they were like sliced in parts, I would advise you to watch all the parts of indices so that you don't struggle through exponential equations, okay? Because you will be using part of those laws within the exponential equations. Good. Now, once you have 1, because now basically you need to make the bases the same. So now to make the base the same on the right hand side where we have a 1, we'll have to use the zero exponent law. Now you just look on your left hand side. Whatever base is there, you raise it to the power 0. Now remember the zero exponent law states that if you raise a number to the power 0, it's equals to 1. You can even try it on your calculator. To raise 3 raised to the power 0, it will give you 1. Even if you raised 5 or maybe 100 raised to the power 0, it always gives you 1, okay? So with that said, what would our answer be? Once you are at this part, it's the same as our first question. So our bases now are the same. So our answer will be the exponents are equal. So x equals to 0. And that's your final answer. Okay? So remember the zero exponent law, which is in part 2 of the video series, is what we used here. Okay? Now let's check at number 3. How about when the bases are not the same and your exponents look a bit complicated, like something like this? Now, this looks a bit complicated, but it's actually very easy. One thing I would advise you to know is how to find the prime factors, or let me say, write a number as a product of its prime factors. Now, if you don't know how to write a number as a product of its prime factors, I'll be putting a link down below that you should watch at least first before you attempt these questions. But if you already know, then you can continue, okay? Good. So what do we do when we have something like this? Number 1, we should make the bases the same. Now, how do we make the 8 and the 4, which are our bases, the same? We use their prime factors, okay? Now, how do we do that? Now, here's one method that you can use to do just that. Start with a bigger base, which is 8. Now, we divide 8 by the first prime number, which is 2. What do we get? We get a 4. So we see if we divide 4 by 2 again, which is our first prime number of all prime numbers, is it still going to give us an answer as a whole number? Yes, we still get a whole number, which is 2. Now 2 divided by 2 will give us 1, okay? So that means these 2's, if you multiply them, they'll give you 8. Now I understand some people prefer writing these numbers on the right hand side and these numbers on the left hand side. Now by all means, if you are familiar with that, you do it that way, okay? Now, if you have 2 multiplied by itself 3 times equal to 8, how about if you wrote it in exponential form? How will it look like? It will look like this. Now, how do I know it will look like this? Look at the number being multiplied by itself here. What number is it? It's 2. That's why our base is 2 here. Now, how many times is it being multiplied by itself? 1, 2, 3. That's why our exponent is 3. Okay? Now we use the 2 raised to the power 3 to replace 8. Not to replace 2x, but to replace only 8. Now to accommodate the 2x, we'll have to introduce brackets. Okay? So we put the 2x as an exponent outside of the brackets. Okay? So now let's change the base of 4. Now when you have 4 divided by 2, it gives you 2. 2 divided by 2 gives you 1, meaning 2 multiplied by 2, which is the numbers that we got here, equals to 4. Now however we wrote this in exponential form, it will look like this. So why is it 2 raised to the power 2? Because the number being multiplied by itself is 2. And how many times is it being multiplied by itself? Only 2 times. That's why it's raised to the power 2. So we replace the 4 with this. Not the exponent, but only the 4. Now to accommodate the exponent, we introduce brackets. And then we write the exponent outside of the brackets. Okay? Now what do we do from there? We use the power law of indices. Remember the power law, which means we multiply the exponent outside of the bracket with the exponent inside the bracket. Not the base, but the exponents, okay? On both sides. So let's do just that. Now when we look at our first side, like the left hand side, 2x multiplied by 3 will give you 6x. The base remain the same. How about on your right hand side? 4x multiplied by 2 gives us 8x. Negative 1 multiplied by 2 gives us negative 2. Okay? Now from here, it's the same as our first question. Notice that our bases now are the same. Okay? Now if our bases are the same, what does that mean? That means our exponents are equal. So now if our bases are equal, we write them as such. Now what do we do from here? From here it's a linear equation. So you can just solve for x. Okay? So subtract 8x on one side, we do that on the other side as well. So it cancels out on this side. We are left with a negative 2. And then 6 minus 8 equals to negative 2. Because these are like terms, we subtract them as well. So now if we have negative 2x equals to negative 2. How do we get the x? By dividing negative 2 on both sides. So on this side, the negative 2 will cancel out and we are left with a x. While on this side, negative 2 divided by negative 2 gives us a positive 1. Okay? And that is our final answer. So let's check into some extra examples. How about when you have something like this, whereby you have a fraction involved? What do we do? First of all, let's make the bases the same. Now one will wonder which bases are we going to make the same, since this side we have a 2, but on the other side we have a fraction, or a 2 raised to the power negative x. But on the right hand side we have a fraction. So what do we do? The bases that we are talking about is this 4 and this 2. Okay? So let's do that by using its prime factors. Now let's start with a bigger number. The reason I always say start with a bigger number is because sometimes you might find that the smaller number doesn't need to be changed. Okay? Let's start with 4. 4 divided by 2 gives you 2. Now 2 divided by 2 will give you 1, which means 2 multiplied by 2 equals to 4. Now in exponential form, that will look something like this. Okay? Now let's use that to replace our 4. Now remember 4 was a denominator, so when we put it here, it still is the denominator. Okay? On the other side, the 2 raised to the power negative x stays the same way it is. Good. Now I want you guys to remember the negative exponent law in part 3 of the indices series, where I told you guys about the reciprocal, okay? Or reciprocal. Now what does the reciprocal mean? The reciprocal simply means to flip whatever is in the numerator to go to the denominator, and whatever is at the denominator to go into the numerator. Okay? So now once you flip them, it has an effect on the exponent sign. Say for example, the exponent was a positive number. Once you reciprocate the number, the exponent becomes negative. If it was a negative number, it will become a positive. So what is the reciprocal of this number? It's this number. Okay? So we flipped whatever was at the bottom, we put it on top, and whatever was on top, we put it at the bottom. Now, notice that the exponent was a positive number, but once we flipped it, it became a negative number. Okay? So now one thing I want you to notice is anything raised to the power 1 is just the number itself. You know, even if you type into your calculator 5 divided by 1 is just 5. 100 divided by 1 is just 100. 500 divided by 1 is just 500. Now given that 2 raised to the power 2 is divided by 1, we can just write it as 2 raised to the power negative 2. Okay? Just the same way it is here because it's divided by 1. Good. Now, on the other side, you bring down the 2 raised to the power negative x just the same way it is. Now notice one thing once you reach here. Your bases are the same. Now what did we say from the previous videos? I mean like from the previous examples. If your bases are the same, then your exponents are equal. So let's bring out our exponents. They are negative x and negative 2. Now remember, we are not solving for negative x. We are solving for x only, which means this is negative 1x. So how can we get rid of the negative sign? By dividing by negative 1 on both sides. Okay? So what is negative 1x divided by negative 1? It will give us x. What is negative 2 divided by negative 1? It gives us a positive 2. And that is our final answer. Okay? Now, how about when you have a question that has a decimal number? What do you do? Say for example, this number 5 has 10x equals to 0.01. Now, what do you do here? Number 1, make the decimal a fraction. Okay? Now, if you don't know how to make the decimal number a fraction, there is actually an easier way to do it on your calculator, which is by pressing 0.01 and then you press the equal sign. Now, after you press the equal sign, the answer will still be 0.01. And then you press your ABC, which is this button. Once you press this button, this should be your display on your calculator. It will show you that this decimal number as a fraction is 1 over 100. Okay? So let's write our decimal number as a fraction, which means this 0.01 is 1 over 100. Now what do we do from here? Now we follow what we did here. Okay? Which is to make the bases the same. How do we do that? By using the prime factors. So let's start again with the bigger one, which is 100. So we say 100 divided by the first prime number. If you know the prime numbers, the first prime number is 2. So 100 divided by 2 will give you 50. Now 50 divided by 2 will still give you a whole number, which is 25. But now when you get to 25, you notice that if you divide 25 by 2, it won't give you a whole number. It gives you what? It gives you a decimal number. So you move up to the next prime number, which is 3. If you divide 25 by 3, Does it give you a whole number? No. It gives you also a decimal number, which means you move up again to the next prime number, which is 5. Now when you divide 25 by 5, does it give you a whole number? Yes. It gives you a whole number, which is 5. So you divide 5 again by 5, which gives you 1. So what numbers do you get this side? 2, 2, 5, 5. Okay? So which means when you multiply 2 by 2, multiplied by 5, and another 5, it gives you 100. Now how do you write this in exponential form? You write it like this. So you write the 2 multiplied by 2 as 1, because there are two 2's, you write the 2 as the base, and because there are 2 multiplied by each other, you raise it to the power 2. Then you multiply it by this 5's. How many 5's are there that are multiplied by themselves? There are 2. Hence, the 5 here is also raised to the power 2. Okay? Now, I want you to notice one thing. When you get here, your exponents are the same. So what can you do? You can multiply your bases, which is 2 multiplied by 5. What do you get? You get a 10, and the exponent stays the same. Okay? Now, if you doubt this answer, you can test it in your calculator. If you press 10 raised to the power 2, it will give you 100. The same as 2 times 2 times 5 times 5. It will also give you 100. Okay? So we replace that 100 with what we got here. Okay? So what do we do from here? Remember the exponent, like negative exponent law, whereby we spoke about the reciprocal? We reciprocate this number, which will give us this number. Now notice that the exponent, which was a positive, became a negative. Okay? So anything divided by 1 is that number itself. So we will have the answer is just 10 raised to the power negative 2. Okay? Now from here, what do we do? The bases are the same. So which means our exponents are equal. So x equals to negative 2. And that's your final answer. Okay? So let's look into some extra examples. So, how about when you're told to solve for y and you're given something like this? Now, I want you to notice that these two bases are the same, but here you have a 1. Okay? So, what do? You make all bases the same, including this one. Now, how do you make this one the same as the other bases? Remember the negative exponent law that I told you from the previous examples? So you check what bases do you have on the left hand side. You have 3. So using the zero exponent law, you raise that same 3 which is on the left hand side as the base. You make it a base on your right hand side and you raise it to the power 0, which means it's the same as 1. Okay? Now from here, we can see that our bases are the same. But when you look at your left hand side, there is a multiplication sign in the middle. Okay? So what do we do with that multiplication sign? We carry out the multiplication law. Okay? So, what does the multiplication law state? If you watched the previous videos, the multiplication law states that if the bases are the same, you add the exponents. So what are our exponents here? Our exponents are y and then 2y minus 2. So when we add them, we'll have y plus 2y minus 2. Okay? Now, how about on the right hand side? The 0, which is the exponent, just comes down the same way it is. Now from here, notice that you have two like terms. So you add them. You say 1y plus 2y will give you 3y. The negative 2 comes down the same way it is, as well as the 0. Okay? Now what do you do from here? It's a simple linear equation. So you add 2 on both sides, which will cancel it on the left hand side, and you are left with a 3y. And on the right hand side, you are left with a 2, because 0 plus 2 will give you 2. Now what do you do from here? 3y is the same as saying 3 multiplied by y, so we can cancel it out. We can cancel this 3 by dividing both sides by 3. Okay, because remember, we don't want 3y, we want y. So dividing it by 3 will cancel it out, and we are left with a y. And on the right hand side, we are left with a 2 over 3. And that's your final answer. Okay? Now how about number 7, when you have something like this, whereby on the left hand side, you have two numbers which are multiplied as well as another number on the right hand side of the equal sign, but none of them are equal. None of the bases are equal, or none of the bases are the same. What do? We make the bases the same. Okay? So let's start with the big or the largest base. Which one is the largest base? 8 is the largest base. So when we divide 8 by 2, we get 4. When we divide 4 by 2, we get 2. 2 divided by 2 gives us 1, which means 2 times 2 times 2 equals to 8. In exponential form, it will look like this. So we replace our 8 with this. Okay? How about the next one, which is 4? When we divide 4 by 2, it will give us 2. 2 divided by 2 will give us 1. How many 2's are here? There are 2 multiplied by 2 gives us 4. Now how do we write it in exponential form? It will look like this. So we replace our 4. Remember guys, you are not replacing the exponent, you are replacing the 4. So if you are replacing the 4, you will have to introduce brackets to accommodate the exponent. Okay? So you write the exponent outside the bracket. Now I want you guys to notice that after changing the 4, you notice that all bases are 2, even the first one that we didn't change. So meaning we don't really need to change this one anymore. Okay? So we just bring it down the same way it is. Now from here, we need to get rid of the brackets. Okay? So how do we get rid of the brackets? By using the power law. So the power law states that you multiply the exponent outside of the bracket with the exponent inside the bracket. Not the base, but the exponent. Okay? So after you multiply it out, it will look like this. Because 2 multiplied by y is 2y. 2 multiplied by -1 is -2. Okay? So from here, it's actually the same as here. Okay? So what do? Although all your bases are the same, here you have a multiplication sign. So what do we do when we see a multiplication sign? We use the multiplication law. What does the multiplication law state? It states that if your bases are the same, you need to add your exponents. So let's do just that. So our first exponent was y plus 1. So here is our y plus 1. And our second exponent was 2y minus 2. So our y plus 1, we will add the second exponent, which is 2y minus 2. What about on the right hand side? Our 3, which is the exponent, stays the same. Okay? So from here, notice that we have two like terms, which is 1y and a 2y. So it's 1y plus 2y will give us like a 3y. And we also have another like terms here, which is this 1 and this negative 2. So after adding 1y plus 2y, it gives us 3y. Now what is positive 1 minus 2? It gives us negative 1. Okay? And then the 3 comes down the same way it is. Now from here, it's again a simple linear equation that you can solve by adding 1 on the left hand side and also adding 1 on the right hand side. So it will cancel out on the left hand side and you are left with a 3y, while on the right hand side 3 plus 1 equals to 4. Now remember, here it says 3y equals to 4 and we are not looking for 3y, we are looking for y. So 3y is the same as saying 3 multiplied by y. To cancel out the 3, we divide both sides by 3. So on the left hand side, it will cancel out and the y is left. While on the right hand side, the 4 over 3 is our final answer. Okay? Now thank you very much for watching this video. If you found this video helpful, please do like, subscribe, turn on that notification button to be the first to see the next upload, share with friends, family, and classmates. And remember, together we rise to higher heights, apart we all stay behind. Cheers.